What up, 8th grade? Welcome to section 3. We're in arithmetic sequences now. We're halfway through chapter 2, so let's get rolling. I hope you like my new intro because we're going to be hearing that one a lot. So we'll see how it goes. First off, talking about arithmetic sequences. We need to know what a sequence is. A sequence is simply a set of numbers in a specific order. All right, we don't have any just random set of numbers. They have to have a specific order, like 2, 4, 6, 8, 10, and so on. Or we could list the odd set of numbers, 1, 3, 5, 7, 9, 11, and so on. Okay, that's a sequence. It has a specific order to it. All right, a term in the sequence is just a specific number. It's called a term. Okay? We determine which term we're looking at using the notation a sub n. So if I take a look at this even sequence of 2, 4, 6, 8, 10, I say that 2 is equal to a sub 1 because it's the first term. 4 is equal to a sub 2, 6 is equal to a sub 3, and so on. So if I were to ask, what is the a sub 7 sequence, or what is the a sub 7th term, that's what I'd be looking for, the 7th term. Okay, so this n, all that means is I can plug in any number for it. The A is telling me that I'm looking for a number in the sequence, a specific term. Okay? The arithmetic sequences. What makes it arithmetic? We've talked about a sequence. We talked about what the terms are in the sequence. Now I need to know what the arithmetic sequence specifically is. And what makes a sequence arithmetic is that the difference between each term is common, meaning I have the same distance in between each. Okay, if I look 2, 4, 6, 8, 10, if I go back to that one, every time I go, I'm adding 2. Okay, that makes this arithmetic. An example of one that would not be arithmetic would be 1, 2, 4, 8, 16. Because in this case, I'm multiplying by 2. Okay, so this is not arithmetic. All right, we see the difference there. Arithmetic means I'm adding or subtracting every time. Not arithmetic is multiplying and dividing, and that's actually something that's called geometric, but you're not going to talk about that this year. But multiplying and dividing is geometric. Adding and subtracting in between each term is arithmetic. All right, so the common difference is the increase or decrease in an arithmetic sequence. Okay, so again, 2, 4, 6, 8, 10. Keep going back to this example. The common difference is going to be 2 because it's going up 2 each time. If I were to start at something like 4 and say 1, -2, -5, and so on, my common difference would be -3 because it's going down 3 each time. Okay, so that's all a common difference is. Do a couple examples here. Identify the common difference and determine if it's arithmetic. So if I look here, 1 to 2, that means I went +1. 2 to 4, I did +2. 4 to 8, I did +4. Right away, I can stop. I don't even have to keep going. I know it has to be the same adding in between each one, so this is not arithmetic, which means it does not have a common difference. Okay? If I look down at B, to go from 1/2 to 1/4, I know I went down a 1/4. To go from a 1/4 to 0, I went down a 1/4. go from 0, I went down a fourth again, and here I went down a fourth again. So my common difference is negative 1/4, and this is arithmetic. Arithmetic. All right? So that's all you're doing with sequences there, is determining if it's arithmetic or not and finding the common difference if it is. Okay? That should be pretty easy. A lot of that might be review. On the back now we have some new material. Okay? This is where it starts to get a little more complicated. We're going to be using a lot more algebra involved. Okay? The nth term signified by a sub n, we know what that means, of an arithmetic sequence with the first term is a sub 1. We already talked about that. And the common difference, which we call d, is given by, meaning the formula for finding the nth term in a sequence is a sub n, our nth term in a sequence, is equal to the first term, a sub 1, plus n minus 1 times d. Okay? That's a formula you will have to memorize. I will not give it to you on the test. You need to know that. It needs to be memorized. Okay? Remember, a sub n is just the nth term. A sub 1 is the first term. D is the common difference. And n is a positive integer. Okay? All right, let's take a look at this first example here. Find the 14th term in the sequence 9, 17, 25, 33. Okay? We could continue to add 8 every time until we got far enough out. That's going to take you a really long time. So let's go ahead and use this formula. We had a sub n is equal to a sub 1 plus n minus 1 times d. So let's find all these things. A sub n, I don't know it. A sub 1, what's the first term in my sequence? It's a 9. N, the term number we're looking for, is 14. And d, the common difference, I already stated it earlier, is plus 8. So now all we have to do is fill it into our formula. We don't know a sub n, so it stays. A sub 1 is 9 plus n is 14 minus 1 times d, which is 8. Now we're just simplifying. Do inside the parentheses first. So 14 minus 1 is 13. I do 8 times 13. Oh, I know 10 times 8 is 80. 8 times 3 is 24. So I'm going to get 104. 9 plus 104 gives me 113. So the 14th term of the sequence is 113. Okay? And our last example, very, very similar, but this time they don't want us to tell the exact term in a sequence. We just want to find an equation that represents the sequence that would help us find the exact term. Okay? So in this case, we still don't know a sub n. A sub 1 we know is 12. We don't have an nth term, so we don't know that. And d, let's take a look at our common difference. Well, this goes up 11, this goes up 11, this goes up 11. So d is going to be 11. Okay? Again, we're going to plug it back into this equation for finding the nth term. So a sub n is equal to 12 plus n minus 1. I don't know n this time, so it stays as n minus 1 times d. Now we still need to simplify it. Okay? I hope we're seeing what we need to do to simplify this here, because I cannot do anything with the n and the 1. They can't be subtracted, so I have to distribute. I know it looks a little bit backwards, but we need to be able to see that. So if I distribute, I get 12 plus 11n minus 11. Now I have to combine my like terms. I have a 12. I have a negative 11. I can combine those to have 11n plus 1. So I can find whatever term in a sequence, in this sequence, I can find whichever term number I want by doing 11 times the number plus 1. So if I want the 54th term in the sequence, let's say we want to look for that, we would plug in 54 for n and simplify. All right? Hope you enjoyed section 3. We got 2 more sections coming up. So good luck with that, and I'll see you in class. Bye.